Climate change is one of the most pressing challenges of our time. As the planet warms, the consequences are becoming increasingly severe. To combat this global crisis, we need a reliable and sustainable energy solution. Could nuclear energy be the answer to stopping climate change? While renewable energy sources like wind and solar are crucial to reducing greenhouse gas emissions, they alone may not be sufficient to meet the world's growing energy demands. This has led to a renewed interest in nuclear energy. But is nuclear power a viable solution to our climate crisis? The scientific consensus is clear: climate change is accelerating, driven primarily by the burning of fossil fuels. Carbon dioxide levels have reached unprecedented highs, and global temperatures are rising, leading to more frequent and severe weather events. The need to reduce greenhouse gas emissions is urgent. Fossil fuels, coal, oil, and natural gas, are the primary sources of energy worldwide. However, they are also the main contributors to carbon emissions. Transitioning away from fossil fuels is critical if we are to limit global warming to 1.5 degrees Celsius, as outlined in the Paris Agreement. Renewable energy sources such as wind, solar, and hydroelectric power are essential components of a sustainable energy future. They produce little to no greenhouse gas emissions and are becoming increasingly cost-competitive. However, they face challenges related to energy storage, grid integration, and land use. Nuclear energy is produced through the process of nuclear fission, where the nucleus of an atom is split into two smaller nuclei, releasing a significant amount of energy. This energy is harnessed to produce electricity. Nuclear power offers several advantages over other energy sources. It generates a large amount of electricity with a small carbon footprint. Unlike wind and solar, which depend on weather conditions, nuclear power plants can produce electricity consistently, providing a stable and reliable energy supply. Modern nuclear reactors are designed with multiple safety systems to prevent accidents and minimize risks. Advances in technology have made nuclear power plants more efficient and safer than ever before. Furthermore, the energy density of nuclear fuel is incredibly high, meaning a small amount of fuel can produce a vast amount of energy. Despite its benefits, nuclear energy comes with significant challenges. High-profile accidents like Chernobyl and Fukushima have raised concerns about the safety of nuclear power. Additionally, the issue of nuclear waste, which remains hazardous for thousands of years, is a major concern. While modern reactors are much safer than their predecessors, the potential for catastrophic accidents, however small, cannot be entirely eliminated. Robust safety measures and continuous improvements are crucial to ensuring the safe operation of nuclear power plants. Managing nuclear waste is one of the most challenging aspects of nuclear energy. Spent nuclear fuel and other radioactive waste must be securely stored to prevent environmental contamination. Long-term disposal solutions, such as deep geological repositories, are being developed but remain contentious and expensive. The high initial costs of constructing nuclear power plants, coupled with long lead times, can be a barrier to their adoption. While the operational costs of nuclear plants are relatively low, the economic feasibility of nuclear energy depends on factors such as regulatory environments, financing, and public perception. To understand the role nuclear energy could play in addressing climate change, it's essential to compare it with other energy sources. Nuclear energy produces minimal greenhouse gas emissions throughout its life cycle, comparable to wind and solar energy. This makes it a low-carbon option for large-scale electricity generation. Nuclear power plants provide a consistent and reliable energy supply, unlike wind and solar power, which are intermittent and depend on weather conditions. This reliability is crucial for meeting baseload electricity demands and ensuring grid stability. While the initial costs of nuclear power plants are high, their long-term operational costs are competitive. In contrast, wind and solar power have lower upfront costs but require significant investments in energy storage and grid infrastructure to manage their variability. The future of nuclear energy lies in innovation and new technologies. Small modular reactors, SMRs, and fusion reactors hold promise for addressing some of the current challenges associated with nuclear power. SMRs are an emerging technology designed to be safer, more cost-effective, and easier to deploy than traditional large reactors. Their modular design allows for scalable and flexible deployment, potentially making nuclear power more accessible and economically viable. Fusion energy, which powers the sun, has long been considered the holy grail of energy sources. Unlike fission, fusion produces minimal radioactive waste and has an almost limitless fuel supply. While practical fusion power remains elusive, ongoing research and advancements bring us closer to realizing its potential. The future of nuclear energy will also depend on policy decisions and public perception. Effective regulation, public engagement, and international cooperation are essential to address safety concerns and build trust in nuclear energy as a viable solution to climate change. To effectively combat climate change, a balanced approach that integrates various energy sources is essential. Renewable energy, nuclear power, and energy efficiency measures must work together to create a sustainable and resilient energy system. Our future depends on the choices we make today. By embracing a diverse and balanced energy strategy, we can meet the urgent challenge of climate change and ensure a thriving planet for generations to come.